What is the Kruskal-Wallis test? When to perform this test and how to perform this hypothesis test? In this video, we will try to understand that. The Kruskal-Wallis test is a non-parametric equivalent of the one-way ANOVA test. This test is performed when the assumptions about the one-way ANOVA test are not met. For example, if the distribution of data is not normal, we cannot perform the one-way ANOVA test. We, in that case, perform the Kruskal-Wallis test. The Kruskal-Wallis test is often performed to test whether the difference between the medians of two or more groups are statistically significant. For example, let's say employees of a company work in 3 shifts. The company now wants to know whether there is any statistical difference between the median salaries of these 3 groups. To determine that, we can perform a Kruskal-Wallis test. Please note that the dependent variable in this case is the salary, and this dependent variable should be ordinal or continuous in the case of the Kruskal-Wallis test, and the independent variable should consist of 2 or more categories or independent groups. Also, the observations should be independent of each other. Now, let's look back at our example. Let's say we have the following data. The null hypothesis in our case is that the median salaries of the 3 groups are the same, and the alternative hypothesis is that the median salaries of these 3 groups are not the same. Let's also assume that the level of significance is 0.05. Firstly, we need to rank the salaries of the combined groups in ascending order. After the ranking, the table looks like the following. Please note that the salaries associated with ranks 9 and 10 are the same. So, we will replace the ranks with the average rank 9.5. Similarly, ranks 16 and 17 should be replaced by the average rank 16.5. So, now the table should look like the following. Now, we will calculate the sum of ranks for each group. The sum of ranks for group 1 is R1 is equal to 126 after calculation. The sum of ranks for group 2 is R2, that is 165 after calculation. And the sum of ranks for group 3 is R3 is equal to 174 after calculation. Now, the test statistic is calculated using the following formula. H is equal to 12 divided by capital N into capital N plus 1 into summation from I is equal to 1 to 3 1 by small ni into Ri minus small ni into capital N plus 1 divided by 2 whole square. Here, capital N is the total number of observations, that is 30 in our case. Small ni is the number of observations for group Y, that is 10 in our case. So, after putting all the values, we get the following. Capital H is equal to 1.68 after calculation. Now, we will look into the chi-square table to get the critical value. The degrees of freedom in this case is the number of groups minus 1, that is 2 in our case. From the chi-square distribution table, the critical value for 2 degrees of freedom and alpha is equal to 0.05 is equal to 5.99. As our test statistic, which is 1.68, is less than the critical value of 5.99, we fail to reject the null hypothesis. Therefore, we can conclude that the median salaries of these 3 groups of employees are the same. I hope this helps. Interested viewers who want to know more, please visit the website of the Security Buddy or refer to the playlist Statistics for Machine Learning. The relevant links are provided in the description. You may also want to subscribe to us and get notifications on recent videos.